Most of us ride in an elevator almost every single day without even thinking about it. But what if I told you that every single ride is actually a constant battle against these hidden, powerful forces? Well, thanks to a really fascinating analysis from Novin Pooya elevator, we're going to pull back the curtain and uncover the invisible physics that make this simple trip a massive engineering challenge.
You know exactly what I'm talking about, right? You're just standing there in the elevator, the door opens, someone steps in, and for just a split second, the whole car kind of dips. That little jolt. You probably just write it off as the car settling under their weight. But the real story is, well, it's a lot more dramatic than that.
You see, not jolt is a symptom of something that engineers call a dynamic force. It's not just weight, it's a sudden, powerful impact that goes way beyond the simple, static weight of a person. It's this hidden force, and believe me, it's waging a constant, silent war on the entire elevator system.
So to really get what's happening here, we need to break down the two main players in this little drama. You've got the predictable static force, and then you've got its chaotic, unpredictable twin, the dynamic force.
Think of it like this. Static force, that's the easy part. It's just the predictable, combined weight of the elevator car and everyone inside, just chilling, standing still. But the dynamic force, that's the real troublemaker. It's not a steady weight, it's more like a shock wave, a sudden jolt created by any abrupt change.
So where do these forces even come from? Well, pretty much everywhere. A passenger hopping in quickly, people just shuffling around to make a little more room. In a freight elevator, it's a huge one, a forklift just rolling on in. Heck, even the quick opening and closing of the doors creates these tiny dynamic loads. These aren't rare events. This is the everyday life of an elevator.
So you might be wondering, how do you even measure a force like this? Well, engineers use something called a dynamic factor, and the analysis from Novin Pooya even gives us the original Persian term for it, which is zaribe dinamiki. It's basically just a multiplier that tells you how much bigger that sudden impact force is compared to the actual static weight.
And this is where it gets absolutely wild. That dynamic factor can be anywhere from 1.2 all the way up to 2. That means when a person steps into an elevator, the impact on the system can be up to twice their actual body weight. It's less like you're stepping on a scale and more like you're dropping a heavy dumbbell on it from a couple feet up.
Now, a single jolt might not seem like a big deal, but these little impacts happen thousands, even millions of times over an elevator's life. And all that adds up, causing slow, silent, and cumulative damage to almost every single part of the system.
So first, let's look at the wire ropes. These are the literal lifelines of the elevator. Every single one of those jolts sends a tiny stress wave shooting through them. Over time, this causes what's called premature fatigue, slowly making the steel weaker. These dynamic forces also cause tiny micro-slips against the main pulley, basically grinding away at the rope and cutting down its lifespan and safety.
And those same forces go to war on the sheaves. Those are the big, grooved wheels that the ropes run over. The jolts wear down the grooves unevenly, which can seriously reduce traction. And the bearings inside those wheels, which are supposed to allow for smooth rotation, just get hammered by these shock loads. This leads to damage, more vibration, and that much noisier ride we all hate.
Okay, let's talk about the heart of the system, the motor. It's trying its best to provide a smooth, steady pull, but these dynamic forces create these sudden, crazy spikes in the torque it needs to deliver. The control system just struggles to keep up, and that leads to all those jerky movements. All this extra work also means the motor wastes energy and even runs the risk of overheating. And finally, let's talk about the car itself, the actual box you're standing in. The frame takes the brunt of these impacts, putting a ton of stress on all the welds and bolts. With freight elevators, you get these big lateral forces from things like forklifts, and they push the car against the guide rails, wearing them down. This is the structural stress that you actually feel as vibrations and jolts. Okay, so that's the problem. And I know, it sounds a little daunting, right? But the good news is there are some really sophisticated engineering solutions to tame these hidden forces. Let's take a look at the comprehensive approach that Novin Pooya lays out.
So the first line of defense is just being smart about it. Modern systems use these super high-precision sensors right under the car floor to detect a change in weight instantly. That data gets fed to an advanced control system, which then tells the motor's VVF drive to smoothly adjust its torque before you can even feel the jolt. It's proactive, not reactive. It's a game changer.
The second step is just building a tougher elevator from the ground up.
This means using higher quality wire ropes and bigger sheaves to reduce that fatigue we talked about. It means shaping the grooves in that sheave, using a U shape instead of a V shape to kind of cradle the rope and reduce wear. And it means using heavy-duty bearings and a reinforced car structure designed specifically to absorb these kinds of impacts day in and day out.
And the third, and maybe most crucial step, is realizing that this isn't a one-and-done kind of fix. Proactive maintenance is absolutely key. We're talking regular inspections to look for those early signs of wear and tear, using special gauges to measure the wear in the sheave grooves, and even doing vibration analysis to detect hidden problems before they become serious failures.
So when you put it all together, you can really see this complete philosophy at work. For every single problem that's caused by these dynamic forces, there is a specific targeted solution. Premature rope fatigue, that's met with better materials and better design. Those jerky motor spikes, they're smoothed out by smart algorithms. And the structural stress, that's absorbed by a reinforced frame. It is a total system approach.
And this quote from Novin Pooya just sums it all up perfectly. The goal isn't just to check a box and meet the minimum safety standards. The real goal is to master these hidden forces to create an experience that is smooth, silent, and just fundamentally stable for every single person on every single ride. So, the next time you step into an elevator and feel that little jolt, you won't just feel it, you'll understand it. You'll know all about the silent battle happening between static and dynamic forces, and you'll have a brand new appreciation for the incredible engineering that's working hard just to give you a perfectly smooth ride. Thanks for joining me for this explainer.